Hello everyone, welcome to our Physics Thinker channel. Wow, our great scientist Albert Einstein did not start with heavy questions for his whole experience. What the question he will be asked about the nature and the science. Let's start for our Albert Einstein ideas with questioning. He asked a simple question that means the question changed physics forever. What was the question, my dear viewers and subscribers? Let's start. What happens to time and space when things move very fast or when gravity gets strong? That was the simple question of Albert Einstein. Let's imagine here we can see this earth around the satellite, space and time as a stretchy fabric. We can observe in this picture. Let's start massive objects like planets and stars. We can see this curved shape, the earth and the satellite. What was this connection? Press into that fabric and make it curve. We can observe in this picture very clearly. Mass bends, space gravity follows. We can see the satellite connection through our cell phones. Are you getting my point? Relativity is not only for black holes. It matters for our cell phone connection through satellite. We can see this picture. GPS satellites orbit have our Earth. That means engineers apply Einstein's correction every second, or otherwise our location could be off by kilometers. You know the question between the space and the gravity. GPS satellite clocks tick at different rates than clocks on the ground because of gravity and speed. You know, Earth is rotating. GPS needs Einstein's correction. That means the time and the space between the gap. Not Einstein theory, but relatively great effects. That means the person on at the left, astronaut on the right. Two clocks connected by glowing ribbon. What was that? That means speed changes time. We can observe the day and night. The faster you move, the slower your clock ticks compared with someone standing still. You can observe this picture very clearly. For everyday speeds, this effect is tiny, but it will be thankful, my dear subscribers. Or in a weak gravity from Earth, the difference becomes measurable. Practically, experiments astronauts prove this time is not the same for everyone. The astronauts travel in the space. That means they are like this. Time dilation will be there between the astronauts. Push relatively to the extreme and you meet black holes. My dear subscribers, their gravity bends space and time so dramatically that light itself curves around them. That was the main matter of the gravity and time. Near a black hole, processes slow for a distant observer. Clocks appear to crawl. You know, can see this picture very carefully. There are not just thought experiments. By observing this picture, you can get this idea. What about the time and the space gravity? We have seen signature of these effects with telescopes and gravitational waves. Let us imagine we can take the telescope and the time we can compare. Hope you understand and like, my dear audience. Relativity is not just a theory in a textbook. Let's move. It's a rule book that runs satellite particles and our view on the cosmos. My dear audience, like to our video, comment your thought in our comment section, subscribe to our Physics Thinkers channel for simple and easy learning. Okay, for new updates. Click on the notification bell to get more cool science updates. Have a nice day, my dear subscriber. Thank you very much for watching our video.